Right, so in this video, let's take a look at a series voltage regulator. It says a series regulator is a type of voltage regulator in which the control element is in series with the load. Right, so let's take a look at this diagram here. This is the block diagram of a series voltage regulator. You have an input, you have another terminal connected to ground, and then you have the output. And the whole point of a voltage regulator is to maintain a constant voltage at the output. And so this is the block diagram of the internals of the voltage regulator. You have a control element, you have a sample circuit, making sure that the sensing the output voltage, and then you have an error detector uh, function, and then a reference voltage. Um, in this book, we can see here that this is the schematic of a power supply. On the output, we have an IC 7812. This is an integrated circuit. It has 3 pins. One is the input voltage, the other one is the output voltage, and the other one is the common terminal or the ground terminal. And in this case, is a 7812 integrated circuit. The 78 means it's a series voltage regulator, and the 12 means that the regulated output is a 12 volts. Okay, so whenever you want to provide 12 volts regulated voltage, this is the IC. There is another one, I believe, the 7805, which outputs a 5 volts a DC current. And so this is the last step in the power supply section. Now let's go ahead and take a look at what's really going on inside a voltage regulator. This is basically what is inside the 7812 or the 7805. You have the sensing circuit. In this case is a voltage divider. This is a sample circuit or the sensing circuit. It's at the output. The load will actually be connected here on the output. And then you have the error detector, which is the operational amplifier. The operational amplifier is going to amplify any difference at the input. So that this section here is sensing whether the output voltage is increasing or falling on the desired voltage. So it's going to reflect that voltage here on the negative input, and then the positive input is taken from this Zener diode, which is providing a reference voltage. So whenever the negative input, which is taken from the voltage divider, falls under the reference voltage, then the operational amplifier is going to amplify that difference. Okay? And the transistor is basically the control element, which is going to provide the current in order to sustain the load. All right, so that is in a nutshell how it works. One thing to notice here is this formula. This is the formula to calculate a non-inverting amplifier, and basically it is R2 over R1 plus 1. This is a closed loop gain of the amplifier. So that's how you calculate the output voltage of the regulator. Let's go ahead and do this exercise here. It says determine the output voltage for the regulator and figure 51. So the input here is a 50 volt input unregulated. We have a series resistor limiting the current through the Zener diode. The Zener diode is a 5.1 volt Zener diode. That's the reference voltage to the positive input. And then on the negative input, we have a voltage divider, and both resistors are 10K each. So the question says, what is the output voltage? The output voltage in this case, what is my pen? Here we go. See if I can. V out is equals to B ref, or the voltage on the Zener diode, times 1 plus R2 over R1. And let me see if I memorized correctly. Yes, it is R2 over R3. Because in this case, this will be the feedback resistor. That's basically what it is. This is a feedback resistor controlling the gain of the amplifier. So if we plug in the numbers, this is equals to the reference voltage, 5.1, times 1 plus 10K over 10K. And this is equals to 5.1 times 2. And this division here is 1 plus 1 is 2. So the output voltage will be 10 volts. This voltage here, 10 volts. All right, so that's the video for today. Thanks for watching.